Okay, so Let's have our class. We're starting with example. A train traveled a distance of 100 meters due east in 10 seconds. What is its speed and velocity? Remember that we said speed is distance over time, the rate at which distance traveled per time. So in that question, distance is given to us as 100 meters, and the time given is 10. So distance 100 times 10. Therefore, speed is 100 over 10. That gives us 10 meters per second. That is the speed. For velocity, remember that speed is a scalar quantity. It's distance traveled with time, whereas velocity is vector quantity, displacement with time. So the displacement in this question is 100 meters due east. So that due east makes that distance to become displacement, because displacement is distance traveled in a specified direction. So 100 meters due east, that is displacement. But if you just say 100 meters, that is distance. So apparently the answer will be the same. The only difference is for velocity, you must include the direction, which is due east. So speed is 10 meters per second. Velocity is 10 meters per second due east. Now the second question, a body rises vertically upward to a height of 100 meters in 5 seconds, then comes back at the same position after another 5 seconds. Find the distance traveled, displacement, average speed, and average velocity of the body. So here we have the body is rising vertically upward to a height of 10 and 100 meters, 100 meters in 5 seconds. Then comes back at the same position after 5 seconds. So what is the distance? The distance is defined as total path traveled by an object. So it moved up 100 meters, comes down another 100 meters. So let's see. So it moved up 100 meters and then comes down to the same position 100 meters. So the total path taken will be, here is 100, here is another 100. So 100 plus 100 will give us the total distance traveled, which is 200 meters. Now, displacement. Remember that displacement is, we can define displacement as change in position. We can say final position minus initial position. Displacement x, that is change in position, is equal to final position minus initial position. So in this case, this is the initial position, which is at point 0. It got to the maximum height and then returned back to the final position, which is also 0. So the displacement will be 0. The displacement will be 0. Our final position is 0. Initial position is 0. If you decide to take that, okay, from here to here is 100, from here to here is 100, that is still 100 minus 100, that would still give you 0. Average speed. Speed has to do with distance. So average speed is total distance traveled over total time taken. The total distance traveled is 200. The total time taken is, it takes 5 seconds to go up, 5 seconds to go up, another 5 seconds to come down. So the total time taken is 10, which means that 200 divided by 10 will give us 20 meters per second. Of course, since displacement is 0, average velocity, which has to do with displacement, will be 0. So another question here for us: a car accelerates from 12 into robots. Okay. So a car accelerates from 12 meters per second to 30 meters per second in 9 seconds. What is the acceleration of the car? What is the total distance traveled through during the period? Now, we are given velocity, initial and final velocity. Here, 12 meters per second is the initial velocity, whereas 30 meters per second is the final velocity, and this is t. So we use equation of motion. V is equal to u plus at, because we have v, we have u, we have t. We are asked to find a. So we set out the equation to be this. So if we rearrange the equation, that becomes a is equal to v minus u over t. We substitute in the values. We have v to be 30, and then u 12, t 9. So 30 minus 12, 30 minus 12 is 18. 18 divided by 9 is 2. So that is our acceleration, 2 meters per second square. Now, the second part of the question says, what is the total distance traveled? Total distance traveled. So you can use S equals to UT plus half AT square, half AT square. To solve, you will get the same answer as if you use V square, which is equal to U square plus 2AS. So this second equation is what we use there. So this becomes V square minus U square over 2AS. So that gives, substituting the values gives that answer. 189 meters. 189 meters. Okay, let's use this second equation. Let's try with the second equation and see what we are going to get as well. So U is 12. U is 12. T is 9. Plus half A is 2, T is 9 square. So 12 times 9 is 108. 12 times 9 is 108. Then these two cancels these two. We have a plus. 9 square is 81. So if you add them together, that is 189 meters. So you can get the same answer if you use any of the formula. So let's move on to the next slide. Okay, so here we have a body moving with constant acceleration travel a distance or travel distances 3 meters and 8 meters in 1 second and 2 seconds respectively. A body moving with constant acceleration travels the distances 3 meters and 8 meters in 1 second and 2 seconds respectively. Calculate the initial velocity and acceleration of the body. So here you are provided with two distances and two covered in 2 time frame. We are asked to find the initial velocity and acceleration of the body. So now, if you consider each of those terms, that is, the body moves or covers 3 meters in 1 second, and 8 meters in 2 seconds. Now, each of these case, so we have 2 cases. Each of these cases will form an equation. In as much as we are asked to find initial velocity and acceleration, any of the equation of motion has 4 parameters. 4 parameters. Let's see. V is equal to U plus AT. S is equal to UT plus half AT squared. Then we have V squared is equal to U squared plus 2AS. Now, each of these equations has 4 parameters. So it means that for you to solve or find any parameter, you must have 3 known. So here, if I want to find V, the first equation here, if I want to find V, I must know U, A, and T. If I want to find U, I must know V, A, and T. That is, at any given time, I must have 3 parameters to find the 4th one. However, in this case, we are given 2 parameters to find 2 parameters. We are given distance and time to find initial velocity and acceleration. So let's look at this that contains the 2. We are given distance, that is S, and we are given time, T, to find U. To find U and A. So in that case, we are going to have 2 sets of equations and then solve them quadratically or simultaneously. So we are going to have 2 quadratic equations and solve them simultaneously. So let's substitute. If we take case 1 and substitute into this equation, that will give us this expression. So we have 3 meters, U times T. T is 1, half AT squared. So that gives us this, which is 2U plus A equals 6. All right, so let's simplify it. Now, here we have 3 is equal to u times 1 plus half times a times 1 square. Of course, whatever you multiply by 1 remains the same. So we have 3 is equal to u plus half times a. So if you simplify this, 2 will multiply u, 2 will multiply 3, and then 2 multiply this. So these 2 will cancel. That's multiplying through all terms of the equation by 2. That will give us 6 is equal to 2u plus a. So that's what we have here. Now, the same way, we substitute 8 meters in 2 seconds into the same equation. We have 8 is equal to u times 2 plus half times a times 2 square. So here we have 8 times 2u. Here, one of the 2 we strike out this. So we have 2a. Now we can simplify this further by dividing through by 2. If I divide through by 2, this will give me 4. This will become u. This becomes a. So now I have 2 sets of quadratic equation that I can solve simultaneously. So now if I use method of substitution to solve, here I can rearrange this to be, that is the first equation, to be, you can use any method. You can use the elimination method. You can use substitution method to solve. If you use substitution method, so we have 2u plus a. Okay, since I said we're using substitution method, let me go straight to the substitution method and then solve it out. So if I move this across the equality sign, I will have a is equal to 6 minus 2u. Now, in the second equation, I have u plus a. So instead of putting a, I will put in 6 minus 2u is equal to 4. So here I'll have u minus 2u will be equal to 4. I move 6 across here, minus 6. So this will give me minus u equals to minus 2. So the minus cancels out. I have u equals to 2. Sorry, u is equal to 2 meters per second. U is equal to 2 meters per second. Now, I know that u is 2 meters per second. I can pick any of the equation and substitute. So let me just use this. If I substitute u equals 2, that will give me 2 plus a is equal to 4. So a becomes 2 crosses the equality sign to meet 4. That becomes 4 minus 2 is equal to 2 meters per second square. So my acceleration is 2 meters per second square. My initial velocity is 2 meters per second. So that is how to solve problem like this. So here is another example. A particle is moving in such a way that its displacement s at any time t is given by s is equal to 2t plus 2t squared. That should be 2t squared plus 5t plus 20. Find the velocity and acceleration of the particle after 2 seconds. Now, this kind of question has to do with instantaneous velocity and acceleration, instantaneous acceleration problem. So in that case, we differentiate. So here we have displacement given, velocity is ds over dt, which means that we differentiate the displacement with respect to time for velocity. So if we differentiate this, 2t squared plus 5t plus 20. Now, if we differentiate, this is s. So v, which is the ds over dt, is equal to, we differentiate this. If we differentiate this term, the 2, which is a square, 2t squared, the square comes, multiply this by differentiation formula. That will give us 4t. Because this will be, if we have a n, and if we differentiate, that will be a, sorry, this is a to n. That will be a n minus 1 n. So that is the formula. We are given, if you want to differentiate, this is the formula. So see a raised to power n as any of these terms that are here. So if I differentiate one step, that would be n minus 1, n times a, n minus 1. So now, applying this formula to this, 2 is n. Then, that is this 2 is n, to which t is raised to is n. So t is a. T is a in this formula, n is 2 here. That is, we say t squared. So if I differentiate this, this will be 2t 2 minus 1. So that will give me what? 2t. 2t. So now, if I have 2 already here, so that 2 multiply these 2 gives me 4. That's how I got 4t. Now, for the second one, we have 5t. So, of course, you know that t is raised to 1. So 1 minus 1 times 1. 1 minus 1 gives us 0. Anything raised to 0 is equal to 1. So here I have 5. T has diminished to 1 because it is raised to 1. 1 minus 1 is 1. 1 minus 1 is 0. And anything raised to 0 is 1. So T has vanished to 1 or diminished to 1. So 1 times 5 becomes 5. As for 20, there is no time attached to it. So this is automatically eliminated. So my V is equal to 4t times t, and I'm given that t is equal to 2 seconds. So anywhere you find t, you substitute for V, 4 into 2, you replace t with 2 seconds plus 5. So that is, this gives us 8 plus 5 is equal to 13 meters per second. To find acceleration, A is equal to dv over dt, which implies that you are going to differentiate this again. You are going to differentiate this. So if you differentiate this, remember this t is raised to 1. 1 minus 1, 0. So this t will vanish to 1. So 1 times 4 gives you 4. 5 has no t, so it vanishes. So my A is 4 meters per second squared. So that is our answer. For velocity, 30 meters per second. Acceleration, 4 meters per second squared. A stone is dropped at rest from the top of a cliff. It is observed to hit the ground 5.78 seconds later. How high is the cliff? Now, if you look at this box, there you have what do I know? That is, what are the parameters given? What do I want? What are the parameters or quantity you are asked to find? And first, you have to analyze this question. A stone is dropped. Remember, when an object is falling freely, when an object is dropped from a height, you don't need to give it an initial velocity. So initial velocity is 0. So this is initial velocity 0. Then since the stone is falling vertically, acceleration A becomes G. And because it is falling down, it is a positive G. And that is 9.8 meters per second squared. Now, from the top where the stone is falling, the initial position from that top is considered as a reference point of 0. Then the time given to us for the stone to fall down to the ground is 5.78 seconds. Now we are asked to find the height. If we use x is equal to ut plus half at squared, we will be able to find the height. Now, remember that this is a general equation that can be applied to both horizontal and vertical motion to solve problems of horizontal and vertical motion. So now we want to solve a vertical motion. We have taken condition u is 0, which means that this u is 0, this part is completely 0. Then a is equal to g, so it means that our s you can leave s, or you can change x to y, or you can change s to height, h. Our s is equal to half g t squared, half gt squared. So what is g? G is 9.8, t is 5.78, you square it, and then you simplify. 9.8 1/2 times 5.78 square. So if you simplify this, you get this answer. That is 163.7 meters. Here's another example. A pitcher throws a baseball with a velocity of 43.5 meters. It is determined that during the wind-up and delivery, the ball covers a displacement of 2.5 meters. This is from the point behind the body when the ball is at rest to the point of release. Calculate the acceleration during its throwing motion. Calculate the acceleration during its throwing motion. So you have to identify the parameters given. Initial velocity is not given, is 0. The distance, the displacement is 2.5, and then the final velocity is 43.5 meters. We are asked to find acceleration. So we chose to use this equation because if you say you want to use V is equal to U plus AT. T is not given, so you cannot use this. If you say we should have used U is equal to UT plus half AT squared. T is not given, so we cannot use this as well. So the only one that you can use is V squared is equal to U squared plus 2AS. So here we know the initial velocity is 0, S is given, V is given, so we can substitute and make A the subject. So this will be V squared over 2S is equal to A. So what is V squared? 43.5 square over 2 times 2.5. So that gives us this answer, which is 37.8 meters per second square. So here is another, there are many examples here that you can walk around, go through, and then get yourself grounded and confident to face any similar like problems. So let's move on to projectile. Any object which is projected by some means and continue to move due to its own inertia. So a projectile is an object moving in 2 dimensions under the influence of Earth gravity. And the path taken by the projectile is often called parabola. So here, if you look at the image here, you see a young man there throwing a basketball. So look at the path. Look at the path that the basketball follows. So now, if you look at this, this is where the young man started throw the ball, and the ball is moving upward, as well as moving away from him. So the ball is executing 2 dimensions. The motion of the ball is 2-dimensional. You can't just say that the ball is going up. Yes, the ball is going up. And you can't just say the ball is going forward. No, that is not a good description of what is happening here. The ball is going up, at the same time it's moving away. So the way to solve problems related to this is by applying 2-dimensional equation, which is the vertical and x component must always be present to solve this kind of problem. So projectile motion can be understood by analyzing the horizontal and vertical motions separately. So this is what we have here. We have the object is thrown up with an initial velocity u. So this initial velocity u, since it is going up and also moving away, it is going to have both horizontal component and vertical component. So at every point, as the object is moving in that projectile form or motion, it is going to have both initial velocity on the horizontal component and vertical component initial velocity. So the initial velocity of the horizontal component is given as this, while the vertical component is given as this. Look at it this way. Okay, look at this diagram. The ball is going this way, thrown this way. This is the vertical component. This is the horizontal component. Of course, the ball was thrown at an angle. So if you apply your trig function, V of naught, which is horizontal component, will be the resultant, which is the hypotenuse, cos theta. Cos theta. And then the vertical component will be hypotenuse, that is V of naught sine theta. Sine theta. So that is what we have here. Sine theta, horizontal and vertical component. Now, at the highest point, at the maximum height, that is at this height, maximum height, when an object is thrown with an initial velocity at this height, which is the maximum height, the final velocity is equal to 0. Because at the initial, at the highest maximum height, the object will experience a moment of rest temporarily, then before the object will start coming down. So this moment of rest makes the final velocity to be 0. So if we take this condition to our equation here, V is equal to, this is our earlier equation, V is equal to U plus AT. So for vertical motion, we are going to have V Y U Y plus, if the object is going up, plus minus GT. If the object is going up, it is a minus. If it is coming down, it is a plus. So this time the object is going up. So since the object is going up, it's going to be a minus. So that is Vy is equal to Uy minus GT. So we have said that the maximum height, the final velocity is 0. The initial velocity of the vertical component is V naught, that is initial velocity, sine theta minus GT. So if you rearrange this expression, you have V or U naught, let's leave it at U. That's initial velocity, U sine theta is equal to GT. So the time it will take the object to get to the maximum height, which is T, is equal to U sine theta over G. So this is the time it takes to get to the maximum height. And it is the same time it will take to return to the point from where the object was thrown. So if I throw an object to this point and the object returns, the time the object takes to this height, that is this same time. It will take the same time for the object to return to this point. So if you're asked to find the total time traveled, that is from here down to here, the total time travel, which is called time of flight. capital T is equal to 2 small t. Small t is the time it takes to get to the maximum height, and it is also the time it takes for the object to return from the maximum height to the point where it was thrown. So this implies that the entire time taken for the object to go up and come down is the time of flight, which is equal to u 2u sine theta over g. That is equal to t. That is the time of flight. So note that. And now, so for the maximum height, here we have this equation. The object is going up. That is our initial or general equation is x is equal to ut plus half at squared. So now, since we are talking of vertical motion, we can represent this as y, and then it's going vertical, so our initial velocity will be u of y, not just y, not just u. Then it's going up, so this is a minus, and then our acceleration becomes a g t squared. So if we substitute in the values or the parameters, for instance, uy, which is initial velocity vertically, is u sine theta. Now remember that our time, the time it takes to get to the vertical height, we know that, which is t is equal to u sine theta over g. So if you substitute that for t here, u sine theta over g minus half g, then we have a t here again. So this is u sine theta over g all squared. All squared. Now, if you simplify this expression, you have the maximum height to be u squared sine square theta over 2g. Look at it here. Here you have sine. You have u here. U times u will give you u squared. Sine times sine will give you sine squared theta over g. And this other side, you already have u sine theta over g squared. So you are going to have, and it has a 2. So this is how I've explained it here to make you understand. So we have that expression for the maximum height. Then horizontal range. So now we consider that the object is moving this way. So it's moving from here. This is the original point. So the object went up and then it's coming down. So there's a distance from the initial position to the final place where the object lands, that is along the x-axis. So this time we use this expression from x is equal to ut plus half gt square. Remember that when the object is going horizontal, acceleration due to, there is no acceleration due to gravity. So this part becomes 0. However, the horizontal component of the initial velocity is x, ux. So this gives us u cos theta time. Remember that our time is u sine theta over g. Now, one thing you need to know about this is the object starts here, get to the maximum point, and then returns. So from here to the maximum or time, maximum point as t. Then from the maximum down to this final point as another t. So the time in this equation, the time we use, t, should be doubled. So instead of having it at x is equal to ux t, it should have been x is equal to ux t. The t should be the time of flight, because you have to consider that the object moved up and then came down. So this is the entire duration you are looking at. So that will make our S here, that is horizontal, to have a 2 here cos theta, okay, u square, let's put u square cos theta sine theta over g. So in trig function, a double angle, which is 2 sine theta cos theta is equal to sine 2 theta. So we have our S is equal to u square sine 2 theta over g. So this is our range. This is our range. And so with this, you should be able to solve problems that has to do with projectile. Now, the final point here is the trajectory. The trajectory, which is the path taken by the projectile motion, can also be derived by using this same equation that we have used. Mind you, we have been emphasizing that the motion is two-dimensional. That is y and x. The trajectory motion or the parabolic motion or projectile motion can only be analyzed using 2 dimensions. So which means to get a proper expression for that motion, we should expect to see both y and x component present in that equation. So that is what brought about this final expression. Yeah. So if we use this equation and substitute in the parameters, v, initial velocity, is this, our time is this, from this, s is equal to u of x Yes. U of xt. So t here is equal to, okay, this horizontal motion. So let me make this x. So this is x over ux. And what is our ux? Our ux is initial velocity along the x-axis, which is u cos theta. U cos theta. So our t this time is equal to this. So in place of this t and this t square, we are going to substitute this value. X, be careful, x u over cos theta. So if we substitute that and then simplify, if we substitute that and simplify, we are going to have this expression. And then if you compare this expression to a parabolic equation, which is this, it shows that tan theta is equal to B, and then A is equal to B, and A in that equation is equal to G over 2U square cos square theta, cos square theta. Right. So here we have an example. A goalkeeper kicks a ball with a velocity of 20 meters per second at an angle of 53 degrees. How long is the ball in the air? How long is the ball in the air? Then how far away does it land? How high does it travel? So now we have the initial velocity given to us. We have the angle. We can find the horizontal and vertical component, or we can go ahead and solve using the equation given to us. So here we have how long is the ball in the air is the time we are asked to find. How far away does it land is horizontal distance we are asked to find. How high does it travel? Vertical distance we are asked to find. So we have the table there. What I know, what I want to know. Initial velocity for vertical and horizontal component from this here. So the initial velocity along the x-axis is resolved to this. Initial velocity along the y-axis is resolved to this. So that is what we have here in the box. And then acceleration due to gravity is given. This should be, this is not a negative, it's a positive. The ball is going up. So if we substitute all the parameters, initial velocity vertically, we are asked to find the time. So here, if y is 0, this will cross the equality sign. And then we have one of the square of t will cancel this. I'll be left with v of y, initial velocity of y, 2 of that times divide by g. That will give us our t. So let's substitute and see. We have 2 times 15.95 divided by 9.8. 2 times 15.97 divided by 9.8. So that gives us this 3.26 seconds. How far away does it travel? So that is horizontal distance. Is substitute, and the initial velocity along the horizontal axis has been resolved to be 12.04 times time, gives you this. And then finally, how high? How high? So this time that we solve for, remember, is the time for the entire duration. So it means if it's I, the maximum height we are looking for, we have to divide the time into 2. So if we divide the time into 2 and substitute all the parameters into this expression, that will give us this answer. So I want you to substitute and solve it out and confirm it with the answer we have here. So that is all for now. There are other exercises, but I'll send them to you to practice it.